Okay, we're going to do a few examples of inverse trig functions. And remember, guys, because we're trying to keep them as functions rather than just solving trig equations, which we're going to do a little later, ultimately you are restricted. We have to restrict these things because as you will see when we get to graphing, sine and cosine, and they're continuous waves, and ultimately they would fail the horizontal line test. So in order for us to actually make the inverse, we've got to restrict the range of that inverse. Ultimately, when you're looking for sine, you're looking in the right hemisphere of your unit circle. Same thing for tangent, and it makes sense because they both have y's, right? Sine is y and tangent is y over x. And then cosine, you're looking up here, and secant, you're looking up here. Okay, and those were the only four that we were working with on our worksheet the other day. So ultimately, this is what you're looking for. Number one, when you look at these, remember it's really inverse sine, of 1/2 equals y, really. And really, so it's really asking you sine, I don't want to use y because you guys will think about that. So let's use theta. Yeah, because ultimately then when we do this, we write sine of theta equals 1/2. So we're looking for this theta right here, that angle. And I talked in class about how when we had sine of a letter equals a number, the letter and the number had to switch places, and it cost us $1. And now that we're moving back, we can get our dollar back. But ultimately, you're going to go to your unit circle, and staying in the right hemisphere, you're going to look for the y coordinates that are 1/2. And over here is all we got because down here there's a 1/2, but it's negative, and that's not going to work for us. So for number one, it is 30 degrees or, oh, sorry. Yep, no, 30 degrees. Oops. All right, I'm going to have to switch my stylus. 30 degrees or pi over 6. Okay. All right, so then cosine, you're doing the same thing. So for number two, cosine of what angle is going to give me 1/2, right? You're looking for that angle there. So cosine of what angle gives me 1/2, and ultimately, again, you have to stay in the upper hemisphere. So we are from 0 to pi for this one, where we're allowed to look. And when we do that, we get this one right here, and that's the only one that works. So we get a 60 degrees or a pi over 3. Okay? And then the other one is a little bit yuckier because it's a tangent, it's going to be a y over x. But remember what I told you guys. Ultimately, because we have the radical 3 over 3, you know that you're looking at either 30s or 60s. Okay? That's what you got to look at. You're looking at either one of those two because ultimately, the radical 2 over 2, for that, it's going to reduce your zeros and your ones. It's irrelevant. You're looking at either your 30 or 60, and I hope you put it on your notes and you kept it on your notes that when we do, I'm going to do the 61st radical. No, I'm going to do the 31st. So it would be 1/2 over radical 3 over 2, and of course that is 1/2 times 2 over radical 3 because we have to multiply. Ugh, that's a terrible 3. We are multiplying by a reciprocal, and that would be 1 over radical 3. And of course, when we rationalize that denominator, that's when we get our radical 3 over 3. So again, tangent goes along with sine. You're looking in the right hemisphere, and we actually need the 30 because that gives us what we need. We need a 1/2 over radical 3 over 2. So this is 30 degrees or pi over 6. Good grief. All right, I know what I'm going to do. I'll switch to the other end of that stylus. Just like the other one, I'm going to do 3 more.